Alright, check this one out. This is a neat one because it's different because of this part right here. We have a number multiplied by the angle, and that's why they call it multiple angles. It's like it's a multiple of the angles. But don't let that scare you. You guys can figure this out because just treat that as if it's its own variable, and we're going to solve for 3t instead of solving for x or for theta or anything else. So actually, this one actually can be quite simple. There's only one new step at the very end. So as usual, we start off with some algebra, and we're going to go 2 cosine 3t equals 1. So put the 1 on the other side, and then change it to cos 3t equals 1/2. Okay, well, this is something that you guys could definitely solve if it weren't for that 3t part. So let's just kind of ignore that for the moment. And let's just it's like we're almost going to pretend that this 3t doesn't exist, and we're just going to call that theta, for example. Okay, but it's not actually theta, so just think of it as some angle. Okay, so I'm just going to remove those lines, and we first of all need to figure out where is the cosine ratio equal to 1/2. And, whoops, wrong way. The more comfortable you get with your unit circle, well, where is my unit circle? Oh, I'm going the wrong way, sorry. There it is, right. Okay, so you got to get more and more comfortable with this unit circle, looking for where's cosine 1/2, and here it is. That's the cosine right there. Cosine of the angle is this side, remember, and sine of the angle is this side. So we're looking for where's cosine equal to 1/2, so it's there, and way down here as well. So basically we have two solutions, 5 pi on 3 and pi on 3. Okay, no problemo. So let's go back to our problem. This is not it. This is it. Okay. So what we have then is we found out that not t, but 3t is equal to pi on 3, or 3t is equal to 5 pi on 3. That's what the unit circle told us. And again, as before, I think I went through in another example, we have to remember that it's not just those two angles. So yes, we have this angle, that's pi on 3, but we also have the one that goes all the way around and then hits it again, or all the way around twice and then hits it again. So we have to think about all these coterminal angles. And so the way we write that down is to say, instead of just pi on 3, we say pi on 3 plus any number of 2 pi's added onto it. So that's how we write that n, which is an integer, multiplied by 2 pi. Okay, same thing down here. Okay, so normally we would be done, but again with this problem, we're not trying to solve for 3t, we're trying to solve for t. So in that case, we just go over here, and we have to just divide everything by 3. So no problem, divide by 3, divide by 3, divide by 3, and then we've got our answer. So we have t equals, the 3's cancel, pi divided by 3 divided by 3. Just a quick little scratch note up here. Pi divided by 3 divided by 3. So that equals pi divided by 3 multiplied by 1 over 3, which equals pi over 9. Okay, so we have here pi over 9, and then plus, we should write it this way, 2 pi over 3 n. Okay, same thing down here. Divide everything by 3. Those are going to cancel, so we have t. Again, we're going to divide this by 3, so we have equals 5 pi over 9. Yep, and then divide this by 3 also, plus 2 pi over 3 n. And this, friends, is the answer. Oh, I almost forgot to tell people what that n is. N is an element of the integers. Okay, there we go. So that's it. By the way, quick little side note. Check this out. 2 pi over 3. How does that relate to this function? Guess what? Look at this. Period, as you know, equals 2 pi over b. And look at our b value. It's 3. So that's going to be 2 pi over 3. So actually, what we're adding here is multiples of the period in each time. So just to mention that. And yeah, so that's our answer. Have fun.